Hi there. For this video, we'll be discussing how to multiply and divide rational expressions. So, first, recall that in fractions, when we multiply a fraction, say if we have 12 over 25 times, let's say 5 over 2. What we do is we factor out first before we cancel. So 12 can be written as 2 times 2 times 3 all over 25 can be written as 5 times 5 times 5 over 2. From here, we can cancel out a 2 here and a 5 here. So we are left with 2 times 3 over 5 or simply 6 over 5. So that is how we multiply fractions. For dividing fractions, what we do is if we have a over b divided by c over d, we know that this one is equal to a over b times d over c. So what we do is we convert the multiplication symbol to, the division symbol to multiplication, and then we get the reciprocal of this second term. And from here, it's simply just multiplication. So we do the same process that we have here. So we will apply this same idea in rational expressions. So let's have our first example. Let's have 81 AC cubed all over 36b times 12 a squared c squared all over 27 ab. Let's move this one up. And from here, similar to how we did a while ago, we first factor out these expressions to their simplest form. So first, note that 81 is equal to 3 raised to 4. So we can write this one as 3 times 3 times 3 times 3 times a, and times c cubed is c times c times c all over 36b. Note that 36 is equal to 4 times 9 or 2 squared times 3 squared. So we can write this one as 2 times 2 times 3 times 3 and times b. Multiply 12 is equal to 4 times 3 or 2 squared times 3. So we'll have here 2 times 2 times 3 times a, since we have a squared, and times c all over 27. This one is equal to 3 cubed or 3 times 3 times 3. So we'll have here 3 times 3 times 3 times a times b. After this, it's now time to cancel out. So first, we have 3 out here, 3 here, 3 out here, 3 here, 3 here, 3 here, 3 and 3, and another 3 out here. So that's all for the 3's. For the a, note that we have an a here and an a. And for these a's, that's all the a in the denominator, so we can't cancel any more. Then we have c. For c, there are no c's in the denominator, so we leave that one out. For 2, we have 2 here, 2 here, 2 here, and 2 here. And for b, there are no b's in the numerator, so we leave the b in the denominator. So we are left with we have 1, 2, 3, 5 c's here. So we have c raised to 5. We have 2 a's here. So we have a squared all over the denominator. We have 2 b's. So we have b squared in the denominator. And this is our answer. Let's have this second example. Let's have 6d over d squared minus 1 divided by d squared all over d squared minus 2d plus 1. Now in here, we already have some binomials and trinomials. So to factor this out, we'll apply our factoring methods. For this one, observe that d squared minus 1 is a difference of 2 squares. So we can write this one as d minus 1 times d plus 1. For this one, observe that this one is a perfect square trinomial. So we can write this one as d minus 1 squared. So we have come up with this quickly since we already have an idea on how factoring works. So if you don't have any idea on that, you may check out my YouTube playlist on factoring polynomials. So with this in mind, we can write this one as 6d all over d minus 1 times d plus 1 divided by d squared can be written as d times d all over d minus 1 times d minus 1. Since we have a division out here, what we do is we convert it to multiplication and we get the reciprocal of this. So this one out here becomes d minus 1 times d minus 1 all over d times d, and we retain this fraction on the left, so we'll have here 6 times d all over d minus 1 times d plus 1. And now it's time to cancel. So we have a d minus 1 factor out here, and we also have a d out here. So we will be left with 6 times d minus 1 all over d plus 1 times d, or simply 6d minus 6 all over d squared plus d. And this is the answer. Let's have this third example. Let's have y squared plus 2y minus 3 over y squared minus 5y plus 4 times y minus 4 over 3y squared plus 9y. So from here, to factor these polynomials out, we use our idea on factoring quadratic trinomials. For this and this, for this one, it's already a linear one, so we can factor it out further. For this one, observe that its greatest common monomial is 3y. So with these in mind, we can write this one out as the factored form of this one. You can verify it is y plus 3 times y minus 1. Yep. And the factored form of this one is y minus 4 times y minus 1. Multiply. We have the y minus 4 out here. All over. Factoring out the 3y, we'll have 3y out here. And inside, we are left with y plus 3. And now we can cancel. So first, we have a y plus 3 factor out here. We have a y minus 1 factor out here. And we have a y minus 4 factor out. So in the numerator, we are left with only 1, since every factor was cancelled. And in the denominator, we are only left with this one. Oops. 3, 1. So that is the final answer for this problem. Let's have our last example. Let's have x cubed plus 8 all over x cubed minus 1 divided by x plus 2 all over x squared plus x plus 1. To factor this one out, note that this one out here is equal to x cubed plus 8 equals x plus 2 times x squared minus 2x plus 4. So how did we come up with this one? This is by sum of 2 cubes. And the same goes for this one. We apply difference of 2. So we'll have x cubed minus 1 is equal to x minus 1 times x squared plus x plus 1. Now note that we wouldn't really be needing to factor this one if in case it has a factor, since you will see later that this one would cancel this one. But you can verify that this one is non-factorable or irreducible. So we can write this one as x plus 2 times x squared minus 2x plus 4 divided by x minus 1 times x squared plus x plus 1. Then, since this is division, what we do is we convert it to multiplication and get the reciprocal of this one. So we'll have here x squared plus x plus 1 all over x plus 2. And from here, we can now cancel out some similar terms, which is this one, and this one. So we are left with x squared minus 2x plus 4 all over x minus 1. Now, is this the final answer? Yes, this one is the final answer, since you can verify that this numerator, even though it's quadratic, it is unfactorable or non-factorable anymore in terms of integers. You may be able to factor it, but it will now involve complex numbers, which we don't really focus much more on. And even if you can factor it in complex numbers, you can't really cancel out a complex number with this one. So that is the final answer for this one. Before I end this video, here are 2 exercises. Actually, it's only one exercise that you can work on, but it's quite large or long, I would say. So we have ax minus ay plus bx minus by times x plus y over a squared minus b squared divided by x squared minus y squared all over a minus b. Now, it might look intimidating at first, but you just need to stick to the basics and everything that we learned in this video. But as a hint, to solve this, it will require you to use factoring by grouping. When you figure that one out, solving this will be easy. And that's it. I hope you learned something from this video, and feel free to comment down below your solutions and suggestions and your answers to this exercise. So that's it, and that's all for this video.